Okay, we need to consider the mean of a Bernoulli distribution directly from our syllabus. We need to recognise and determine the mean P. We'll do variance in the next lesson of a Bernoulli distribution for parameter P. Oh my gosh, talking Chinese. We have a formula in our formula sheet under a binomial distribution that the mean is NP. Hopefully by now we recognise that a Bernoulli distribution has one trial, so N is 1. So just for a Bernoulli distribution, we can say the expected value or mean is actually just P, because 1 times P is just P. That's easy, lesson over. No, how does that work? How does that work? Do we recognise, can I make that bigger? How does that work? Mindlessly applying rules is fraught with danger. So we've done an expected value video before, and you've watched it and completely understood it. And we know that the expected value, or mu, is the sum of PIXI, where I is the iteration. We're going to multiply down and then add across. So let's multiply down. What's 0 multiplied by P minus 1? What's 1 times P? And then we're going to add across. What's 0 times P? P. Therefore, the expected value for a binomial, for a Bernoulli trial or a Bernoulli distribution is P. Oh my gosh, that's a surprise because that's what we got up here. That's still clear as mud. I know. What the hell's going on here? What does that look like? Give me a question. Okay. Determine the mean of a Bernoulli distribution where P is 0.47. So you've got mean. That's a rule. The mean is the expected value, is the sum of PIXI. You know that in a Bernoulli distribution, we're either going to get 1 success, 0 successes or 1 success. So here, P is success. So if I get 1 success, it's 0.47. That means this is failure. That would be 0.53. Don't really know why I'm doing this in red, but anyway. So the first PI is multiplying down here. So that's going to be 0 times 0.53 plus, then I'm going to multiply down there and get 1 times 0.47. Put that in your calculator if you like. You're just going to get 0.47. Did you recognise that 0.47 was actually just P? So the mean of a Bernoulli distribution is actually just P. Interesting. On your exam, given that it's so easy, you're allowed to go, hey, I've got a rule for that. There's a binomial distribution that says in a mean is NP. So you can go Bernoulli is a binomial where n equals 1, therefore mean equals NP equals 1 times 0.31 equals, there's our mean. Without understanding that, you're going to have this rule in your formula sheet that is just double Dutch. So you need to understand that a Bernoulli is a binomial distribution where n equals 1. And then it is so easy. If a hair growth potion is it has a 65% likelihood of working, determine the expected outcome if I took the potion. So because there's only one person taking the potion, this is A, Bernoulli trial where n equals 1 and p equals 0.65. So the expected value for x equals np, which is 1 times 0.65, 0.65. So I guess it's a worded question. So you'd say, Mr. Finney has a 65% chance of being hairy. Okay, so I know we did more. It's such a simple rule, but there's so many rules coming your way. If we don't have a good understanding of how that works, of why that works, we are going to struggle to apply that in unfamiliar contexts.